What if I told you that one rider's decision to leave the most dominant team in MotoGP history would completely rewrite the rulebook for motorcycle racing? In 2004, Valentino Rossi literally changed the entire sport, and this is how he did it. Let's set the scene. It's 2003 and Valentino Rossi is untouchable. He's the reigning world champion, riding for Honda, the undisputed kings of MotoGP. Everyone in the paddock knows one simple truth. If you want to win, you ride a Honda. But here's where things get interesting. Rossi, at the absolute peak of his powers, makes an announcement that sends shockwaves through the racing world. He's leaving Honda for Yamaha, a team that hadn't won a championship in years and was struggling just to finish on the podium. People thought he'd lost his mind. The conventional wisdom was crystal clear. Honda had the best bike, the best engineers, and the biggest budget. And the Yamaha's M1? It was considered a lost cause. The bike was unpredictable, physically exhausting to ride, and desperately lacking the performance to challenge for wins. Critics lined up to predict Rossi's downfall. This was career suicide. But Valentino Rossi didn't become a legend by playing it safe. To understand what Rossi walked into, we need to talk about the Yamaha YZR M1 before his arrival. When MotoGP transitioned from 500cc two-stroke engines to four-stroke power plants in 2002, Yamaha rolled out the M1 as their answer to Honda's dominant RC211V. But there was a problem, actually several problems. The early M1 was built around what engineers call a screamer engine configuration, a 5-valve per cylinder inline-4 that fired at perfectly even intervals, every 180 degrees of crankshaft rotation. On paper, this sounds ideal. Maximum revs, maximum power, maximum aggression. But in reality, it was a nightmare to ride. The power delivery was brutal and abrupt. Riders described the throttle response as an on-off switch, as there was no middle ground, no finesse. When you cracked the throttle open exiting a corner, the rear tire would spin aggressively, causing the bike to step out unpredictably. At lean angles approaching 60 degrees, this kind of behavior is terrifying. The chassis struggled too. The M1's handling characteristics were inconsistent, making it difficult for riders to trust the front end during hard braking or maintain stability through fast corners. Lap after lap, race after race, the physical and mental fatigue was overwhelming. The bike demanded constant wrestling, constant correction, constant tension. Honda riders, meanwhile, were dominating with surgical precision. Their V4 engine layout provided smoother, more controllable power, allowing riders to maximize corner exit speed, the single most critical factor in lap times. Yamaha knew they had a problem. They just didn't know how to fix it. Until Valentino Rossi walked through the door. But how could Yamaha possibly transform a bike that was seconds off the pace and physically exhausting to ride into a championship-winning machine in just a few months? And what radical engineering decision did Rossi and his team make that went against everything traditional motorcycle racing wisdom had taught them about four-stroke engine design? The answer lies in one of the most revolutionary technical decisions in MGPT history, and it started with Rossi doing something no other rider had done before. When Valentino arrived at Yamaha ahead of the 2004 season, he didn't just show up to ride the bike. He moved into the engineering department, literally. Rossi and his legendary crew chief, Jerry Burgess, became obsessed with understanding every nut, bolt, and firing sequence of that M1 engine. Traditional MotoGP development went like this. Engineers designed the bike, riders wrote it, feedback was noted, minor adjustments were made. The rider was a pilot, not a partner. Rossi flipped that script entirely. He demanded to be involved in every technical decision. He spent countless hours in meetings with Yamaha's project leader, Koichi Tsuji, and the engineering team. And together they identified the core problem. The Screamer engine was mechanically efficient, but completely incompatible with how a world-class rider needs to manipulate a motorcycle at the absolute limit. So they made a decision that shocked the racing world. They were going to throw out decades of conventional inline-4 engine design and build something nobody had ever tried before. They created the Big Bang engine. Here's how it worked. Instead of firing all four cylinders at evenly spaced intervals 180 degrees apart, they reconfigured the firing order to be dramatically uneven. 270 degrees, 180 degrees, 90 degrees, 180 degrees. This meant the power pulses were grouped together, followed by longer pauses between combustion events. Why does this matter? Because it completely transformed how the rear tire interacted with the track surface. With the old Screamer engine, the rear tire was constantly being hammered with power pulses, giving it almost no time to regain grip between hits. With the Big Bang configuration, those longer pauses between power pulses gave the tire crucial microseconds to recover traction. And the result? Smoother, more predictable acceleration out of corners. Exactly what Rossi needed to exploit his legendary late-braking and mid-corner speed. The Big Bang engine gave the M1 the controllable torquey characteristics of Honda's V4, while maintaining the lighter weight, simpler construction, and narrower profile of an inline-4. It was the best of both worlds, but the revolution didn't stop there. Rossi's feedback drove changes to engine positioning, chassis geometry, throttle response mapping, and suspension setup. Every modification was laser-focused on one goal, making the bike an extension of Rossi's nervous system. And it worked spectacularly. February 2004, Circuit de Catalunya, Spain. The pre-season IRTA test, where teams shake down their bikes before the championship begins. Valentino Rossi, on his brand new Yamaha M1, posts the fastest lap of the entire test session. Then he does it again, and again. The paddock went silent. This wasn't supposed to be possible. Yamaha had been nowhere the previous season. Now, suddenly, Rossi and the M1 were untouchable. Honda engineers stood in their garage, staring at timing screens in disbelief. When the 2004 season started at Welkom, South Africa, Rossi took the M1 to victory in his very first race with Yamaha, as he defeated Honda at their own game, on a bike that most experts had written off as a lost cause just months earlier. 9 victories that season, his first world championship with Yamaha, and a paradigm shift that would echo through MotoGP for decades. But why did Rossi's Big Bang engine philosophy force every other manufacturer in MotoGP, including the dominant Honda factory, to completely abandon their traditional development approach and start treating their riders not as employees but as essential engineering partners? And what specific technical advantage did this rider-centric philosophy unlock that pure factory horsepower could never achieve? The answer reveals the deeper genius of what Rossi accomplished. It wasn't just about building a faster bike, it was about redefining what faster actually means. Before Rossi's Yamaha revolution, MotoGP development was dominated by a simple philosophy: more power equals more speed. Engineers focused obsessively on maximizing horsepower, rev limits, and top speed. The rider's job was to hold on and extract whatever performance the engineers had built into the machine. Rossi proved that philosophy was fundamentally flawed. What he demonstrated conclusively, undeniably, is that the usability of power is far more important than the quantity of power. A 240 horsepower engine that delivers its power in brutal, uncontrollable surges will always be slower than a 230 horsepower engine that allows the rider to maintain perfect throttle control through corner exits. And here's the kicker. This realization required engineers to fundamentally change how they interacted with riders. Think about it. Traditional engineers could measure horsepower on a dyno. They could analyze telemetry and lap times. But they couldn't feel what happened to the bike when it transitioned from 55 degrees of lean to full throttle at 180 miles per hour. Only the rider could. Rossi forced Yamaha to build systems where his intuition and feel became data points as valuable as any sensor. This collaborative approach unlocked something revolutionary: a bike that was optimized not for theoretical performance, but for real-world lap times in the hands of a human being operating at the absolute ragged edge of physics. Honda watched Rossi dominate on inferior hardware and realized they'd been building their bikes backwards. So did Ducati. So did Suzuki. Within 2 years, every factory in MotoGP had restructured their development programs to place the rider at the center of technical decisions. Rossi didn't just win championships. He rewrote the organizational chart of the entire sport, and the technical advantages kept coming. Yamaha shortened the engine stroke to allow higher RPMs while maintaining that crucial Big Bang character. They developed gear-driven camshafts for more precise valve timing. They pioneered rider-adjustable engine mapping systems that allowed Rossi to change power delivery characteristics on the fly during races, something that's now standard across all of MotoGP but was revolutionary in 2004. The M1 became a living, breathing extension of Rossi's riding style. Smooth where he needed smoothness, aggressive where he needed aggression, and infinitely customizable to track conditions, tire wear, and race strategy. It was the ultimate rider's bike, and it changed everything. But here's where the story takes an unexpected turn, one that even die-hard Rossi fans often miss. The Big Bang engine that revolutionized MotoGP and secured Rossi's legacy almost didn't happen. In early development meetings, several senior Yamaha engineers pushed back hard against the Big Bang concept. Their argument was that it was too radical, too risky, and potentially slower than the Screamer configuration they'd spent years perfecting. The Screamer engine produced more peak horsepower. It revved higher. On a dynamometer, it looked objectively superior. Some engineers worried that switching to Big Bang would surrender Yamaha's top speed advantage on long straights, potentially costing them victories at circuits like Mugello and Catalunya. There were heated debates, technical presentations, computer simulations that suggested the Big Bang engine might actually be slower in certain conditions. Rossi and Burgess had to fight for it. They had to convince skeptical engineers to trust a rider's intuition over decades of engineering orthodoxy. They had to put their reputations on the line. And when that first Big Bang prototype fired up, the dyno numbers confirmed the engineers' fears. Peak horsepower was down. Top speed was slightly reduced. But lap times were faster, significantly faster. Because while the bike made less power, Rossi could use more of it, more of the time, in more corners. The throttle controllability translated into earlier acceleration out of turns, which meant higher corner exit speeds, which compounded through every straight and every lap. The engineers who'd opposed the change became its biggest advocates, because the data didn't lie. The Big Bang M1 was a weapon. That's the twist. The innovation that defined modern MotoGP almost never made it off the drawing board. It took courage, conviction, and a rider willing to bet his career on an unproven idea. That's Valentino Rossi in a nutshell. But what permanent, irreversible changes did Rossi's collaborative development philosophy embed into the fundamental structure of MGPT that ensure no manufacturer can ever return to the old engineer knows best approach? And how did this philosophical revolution extend beyond just engine design to transform suspension setup, electronics programming, chassis geometry, and even tire selection into rider-driven sciences that have now become the universal standard across all prototype motorcycle racing? What Rossi permanently changed was the culture of MGPT development. Before the M1 revolution, racing was compartmentalized. Engineers engineered, riders rode, and rarely did the two deeply collaborate. After Rossi's success, that barrier dissolved forever. Today, every MotoGP factory employs sophisticated rider feedback systems. Test riders work year-round providing detailed input. Race riders spend off-season days in engineering facilities, analyzing data and guiding development priorities. This is all normal now. It's expected. But in 2003, it was revolutionary. Let's talk specifics. The suspension systems on modern MotoGP bikes feature dozens of adjustable parameters like compression damping, rebound damping, spring preload, ride height, and more. But those adjustments are meaningless unless they're calibrated to a specific rider's style and preferences. Rossi pioneered the idea that suspension setup wasn't about achieving theoretical perfection. It was about matching the bike's behavior to the rider's inputs. He worked so closely with Öhlins engineers that they developed custom valving specifically for his smooth but aggressive cornering style. Those innovations filtered down to production racing and eventually to consumer motorcycles. And the electronics? Same story. The M1's early traction control and engine mapping systems were primitive by today's standards. But Rossi's insistence on rider adjustability during races pushed Yamaha to develop handlebar-mounted controls that allowed real-time changes to power delivery. Now, every MotoGP bike has multiple riding modes, customizable traction control levels, engine braking settings, and launch control systems, all accessible to the rider during the race. That's Rossi's legacy in action. In chassis geometry, Rossi's feedback led to adjustable swing arm pivot points, variable rake and trail settings, and modular frame construction that allows teams to fine-tune handling characteristics for different circuits. These weren't just Yamaha innovations, they became industry standards. Even tire selection changed. Rossi worked so closely with Michelin that tire manufacturers started designing compounds specifically around rider feedback, rather than just laboratory testing. The modern MotoGP tire allocation system, where riders choose from multiple compounds based on feel and preference, which traces directly back to Rossi's collaborative approach. But here's the deeper point. These technical changes required cultural changes. Manufacturers couldn't just hire smart engineers anymore. They needed engineers who could listen. Teams couldn't just recruit fast riders. They needed riders who could communicate. The job description for a MotoGP rider fundamentally changed.